Hi, this is Dr. Schultz, and on this worksheet, you're going to get some practice figuring out the effect of air resistance on a skydiver. You can see there's a picture on the right that shows someone jumping out of a helicopter and they're opening up a parachute. And what you're going to do in this worksheet is you're going to actually use Newton's second law to find the skydiver's acceleration at different points when they're falling. And so we're going to need to use the Newton's second law, which is the formula that's written over here. And we're going to plug in some values to that to figure out the acceleration of the skydiver. So I'm going to read the instructions over here on the left. It says that Bronco skydives in parachutes from a stationary helicopter. Various stages of fall are shown in positions A through F. And then it says we're going to use Newton's second law to find Bronco's acceleration at each position. So I'm going to stop right there. It's right here. And of course, we know that this is the second law. Acceleration equals net force divided by mass. And what we're going to do with that second law is we're going to look at pictures like this today, where you can see that there are actually two forces that act on Bronco. There's the downward force of Bronco's weight, and there's an upwards force that's due to air resistance. And those are given the symbols W for weight and R for air resistance. And we're going to have to look at those values as he's falling. So when you look at the net force in that equation, you have to subtract those two forces. And I hope you remember that, basically to find net force, if you have two forces in opposite directions, you need to do some subtracting. Okay, so we'll continue with the directions. It says you need to know that Bronco's mass is 100 kilograms, so his weight is a constant 1,000 newtons. And air resistance varies with speed. Okay, so just a quick review on that. Just remember that the weight force is equal to mass times 9.8. And so if you took the 100 kilograms and multiplied by 9.8, you'd actually get 980. But we're going to use approximately just the value of 10 here for the gravitational field strength. So if you take 100 times 10, that's how you get the weight of 1,000 newtons. So please make sure as you're doing this that you know that 1,000 newtons is the weight and 100 kilograms is the mass. That's very important. All right, so I'm not going to do the whole sheet. I'm just going to do the first few cases here, and then you can finish it. So at the very beginning, just go ahead and erase this part. At the very beginning, when Bronco first steps out of the helicopter, basically the only force that acts on Bronco is the weight force. That's 1,000 newtons. That's it. Bronco isn't moving yet, so the air isn't pushing back up on him, so there's no air resistance. So how much acceleration will he have? Basically, they would have an acceleration that's equal to the net force of 1,000, right? That's the weight. And of course, there's no air resistance, so it's just 1,000 minus 0. And divided by the mass of Bronco, divided by 100. So again, we're using the formula. And in the very beginning, there is no air resistance, so the net force is equal to Bronco's weight. So 1,000 minus 0 divided by 100 would be giving acceleration of 10 meters per second per second. And that's basically the same acceleration you have like if there's no air resistance, right? That's the acceleration of gravity. All right, the next part let's do one more here, okay? So in part B, Bronco has clearly started to fall. Well, why did he fall going from A to B? Because he was accelerating. And so he picks up some speed, and that means the air is pushing back up on him. And so now the air is pushing back up on him, maybe with a force of 400 newtons. Okay? So the net force on Bronco is no longer going to be 1,000 newtons. It's going to be less. And so we find acceleration by doing the same math. We take 1,000 newtons of weight minus the upwards force of 400 newtons and divide by Bronco's mass. So again, this is the W force here, this is the air resistance force here, this is the mass. We're literally just plugging into the second law formula. And so you do this maybe in your head or on a calculator. 100 minus 400 is 600, but you have to divide by the mass. So we divide by 100, and that gives an acceleration of 6 meters per second per second. And so there's less acceleration now. And that should make sense because air resistance is going to act to give you less and less acceleration because it's going to be taking away from the net force that acts on you. So I'm going to let you guys finish this the worksheet here. Follow the same math, the same steps, but pay attention to what happens. Something interesting happens here, okay? And when the parachute opens up, other interesting stuff happens with air resistance. And so that's you can do the math on that. And once you finish that, I'd like you to just go ahead and use your data, your calculations to answer those questions, and we'll check in together. Good luck.